Welcome to Module 8.6. In this lecture video, let's take a look at the properties of real numbers. So we've done a lot of these properties before, back in Module 1. So here I'm basically put them all together and kind of present it to you in the in the algebra kind of sense. Okay. So some of these properties is something you already learned before. So we're just gonna present it with a in the algebra kind of sense. So one of the very first property we mentioned before is called a commutative property. Commutative property for addition or multiplication. Okay, for addition or multiplication says for any real number a plus the real number b is exactly going to be b plus a. For multiplication, it's going to be a times b equal to b times a. So basically what commutative property is saying is if I got two terms, then I'm allowed to swap the order of my two terms. Okay, I'm allowed to swap the order of my two objects. So for example, if I have a heart and a star, okay, together, okay, so here I got two terms. Together is called an expression. So within the expression, I am allowed to swap the order of my terms because that still give me the same two term, okay, in the expression. Okay, so what's an expression? Expression is something made out of a bunch of terms. So commutative property allow me to swap the order of my terms. All right. So a times b, multiplication is only one term. So within one term, I'm also allowed to swap the order, okay, within that one term. So basically, if I have a box, okay, let's pretend this rectangle is a box, and inside the box, I have two objects inside of it, okay? So this whole box is only considered as one term. So within that one term, I can move my object around, okay? Almost like I pick it up and shook it around. Then I'm still having the same two objects, same two things, okay, inside that term. So within one term, I'm also allowed to swap the order. All right, associative property, as we mentioned before, it allows me to add or combine, okay, now it's the word combine, not add. It allows me to combine any two terms first of my choice. So if I want to combine A and B first, then combine with C, that should be exactly the same answer if I want to combine B and C first, then combine with the A. Now, I'm purposely using the word combine. Combine means add or subtract. Okay, so I can combine any two terms first of my choice. It's still going to be the same answer. Same thing for multiplication. I can, because multiplication between anything is only one term. So within one term, I can multiply any two number first, okay, of my choice. So if I want to multiply these two numbers, then times the A, which got to be the same thing if I will multiply the A and B first, then times the C. Okay? So commutative property and associative property is very easy to identify when it comes to doing problems like these. All we have to look for is all we got to look for is find what the equal sign is and see what the difference between left side and the right side. So for commutative property, what's different is the order of the term has been swapped between the two sides. For associative property, what is different is the parenthesis. The parenthesis indicates who we want to combine first, and then who we want to multiply first. But check out the order though. If you just ignore the parenthesis for right now, that's A first, B, and the positive C. The right side is also A first, then positive B, positive C. So the order between the two sides never change. What's changing is the parenthesis. One of them is on A and B, the other one's on B and C. So that indicates I'm combining. What I combine first is different between the two sides, or what I'm multiplying first is different between the two sides. All right, we mentioned 0 as an identity for addition back in module 1. So any number is always plus 0 or 0 plus that number, still show itself. Multiplication, any number is always times by 1 or 1 times that number. So the 1 is identity for multiplication. 0 is identity for addition. All right. I mentioned the word inverse, additive inverse. Additive inverse in the previous few modules is regarding to if I got two terms that are exactly the same numerical value but opposite sign, when they combine, they become 0. All right. Inverse for multiplication is basically multiplied by its reciprocal. All right. So inverse of 2 for multiplication will be 1/2 because the 2 multiplied together is equal to 1. All right. The additive inverse of 2 got to be -2 because when the 2 combine, that gives me what? 0. Okay. So one of them is really called additive inverse for addition. The other one is called inverse property. If it is the word inverse, or whenever I say the word inverse only, that's referring to multiplication. All right. Most of the people know this already. Zero factor law means 0 times anything is always 0. We mentioned distributive property before. Okay, so let me formally introduce it here real quick. And in the next module, we will begin to use distributive property. Distributive property says for any real number a times parenthesis b plus c. All right, if you look at what's inside the parenthesis, I'm supposed to combine what's inside the parenthesis first. But here's an issue. When it comes to algebra, this term may not be like terms with the other one. So when these two terms are not like terms, that means they cannot be combined. Okay, they cannot be combined. So that's why I always ask students, hey man, what's b plus c, man? A lot of students say the answer is bc, which is absolutely wrong. Because b and c are not like terms, so you cannot combine them. All right, so what's b plus c? B plus c just b plus c. Because they're not like terms, so I cannot do anything with them. So if I cannot combine these two terms in the parentheses, then the only other operation I can do is the multiplication. All right, so I'm gonna use my a, okay, go inside the parentheses and times my b. So a times b becomes ab. Then we say a times positive c, which will give me positive ac. The whole purpose of distribution is to bring the terms that are in the parenthesis to the outside the parenthesis. Okay. Now, so remember I mentioned before where sometimes we have like a multiplication problem where it simply say 3 times, what was it? 3 times -2, for example. What's the purpose of having a -2 in the parenthesis? Well, the only purpose of the parenthesis is to indicating that there's a negative number inside. Okay, but if you really think about inside this parenthesis, there's only really one term. So when it comes to distributive property, now I'm actually have more than one term in the parenthesis, and our job when it comes to distribution is bring them to the outside the parenthesis. Okay, we'll do a lot of these in the next section, 8.7. Alrighty, so let's try this example. This thing can get a little bit boring after a while. So what we look for here is find the equal sign and see what the difference between the left side and the right side. All right, so on the left side, there are two terms right here. First term is -7. Second term is positive 4y squared. On the right side, positive 4y squared end up going first rather than -7. And -7 is second term. So the difference between the left side and the right side is the order of the two terms has been swapped. So that got to be commutative property. For who? For addition. Okay, because this is multiple terms using a plus sign. All right, find your equal sign. Let's see what the difference is, okay? This is whole thing on the left side is one term because this is multiplication. So I got negative 3z squared. I got an a. I got a negative 2. The left side, negative 3z squared is first. Got an a in the middle. Got negative 2 on the end. So what's the difference? The order are the same, so it cannot be commutative property. So what's different between the two sides is actually the bracket. See, the bracket on the left side is on the a and negative 2. So this is trying to tell you that multiply those two first. But on the right side, the bracket actually has shifted onto negative 3z squared and 8. All right. So the left side is 8 times negative 2 first. The left side is 8 times negative 2. The right side is negative 3z squared times 8 first. So who I multiply first has changed. So that got to be associative property for multiplication. All right. 0. Okay. When you ever see plus a 0, shows itself. All right. Y to the third plus 5 plus a 0 and still show itself. That got to be an identity property. Because identity property is the one that actually plus 0 or times by 1 to show itself. So this one must be the identity property for, where is my identity? For addition. That's called the additive identity property. Okay, because this one is called additive inverse. That's when you see the opposite sign. All right, negative 3y to the third times 1. So when you see the times 1 and still show itself, that will be identity property for multiplication, multiplicative identity property. All right, when it comes to equal to 0, I want you to see, this entire z squared minus 5 plus another z squared minus 5, but this time it's a negative 1. So that means these two has opposite sign. One is positive, one is negative. And so when they combine, they become 0. So that would be the inverse property for addition. So that's called the additive inverse property. All right. Oh, see, this is a reciprocal, right? 3 and 1/3 reciprocal. So this is actually inverse property because it's equal to 1. Inverse property for multiplication. That one is easy. That one is just like the 2 times a half I just wrote earlier. Just inverse. Inverse for multiplication, another way of saying is times by the reciprocal, basically. It's the same thing. All right, 0 times anything equal to 0. So that will be 0 factor law. So this last one, let's see. Oh, got another one right there. All right, let's look at the left and right side, okay? Negative 6 go first times this big old bracket. Now the bracket on the right side go first times by negative 6. So the order of where the negative 6 are located has been swapped from the left side to the right side. So that would be commutative property for multiplication because this is multiplying. This one is hard to see. This one is tough to see. There's so many variables everywhere. But what I'm going to do is I'm going to identify the plus sign outside the parenthesis, okay? So on the left side, I see a y plus 4 is the first term because that's in front of the parenthesis. All right. In the bracket, there's an addition sign. So in the bracket, the next term is positive 5. The last term is positive negative 5, or really just negative 5. Let's use the same color, okay? On the right side, y plus 4 still located as the first. Positive 5 still located as second. Negative 5 plus a negative 5 still located as the third. So the order of the three terms never change between the two. So what's different about them? Well, what's different about them is where the bracket is. See, the left side bracket is on 5 and negative 5. The right side, the bracket is on the 5 and y plus 4. So this must be associative property. Okay, who I combine first is changing. It's different from the left to the right. On the left, I combine 5 and negative 5. On the right, I'm combining y plus 4 and positive 5 first. So that will be associative property for addition. All right, this one will be associated, will be the distributive property. Okay, because where does this negative 42z come from? It actually comes from the negative 6 multiply the 7z. Okay, negative 6 times 7 is where that negative 42 come from. Okay, all right, so in this lecture video, we formally introduced the properties that some of them we mentioned before. And one of the reasons why public school teaches these properties because by the Common Core, there is actually a standard that asks the teacher to teach students these properties and use these properties to solve equations, basically, to solve different types of equations in algebra classes. Now, I mainly use these properties to allow me to do the things that I do in algebra. Okay, I'm allowed to swap the order of my terms. I'm allowed to combine any two terms first of my choice. And a lot of times I do use a lot of identity property and inverse property. I just don't write them all out. Okay, and we definitely use a lot of distributive property. Distributive property is probably one of my favorite properties that I constantly use. Okay, constantly thinking about bring those terms to the outside the parenthesis. All right, that will conclude this lecture video on the properties of real number. Thank you for watching.